And now we're going to take you into a concept called deep energy efficiency. I won't steal Tom's thunder, but I will tell you that as part of his presentation, we'll hear more about, in concrete terms, with a case study on an elementary school where deep energy efficiency happened. Tom?
Thank you. You won't find a definition for deep energy efficiency in the Fundamentals Handbook, so it's going to be up to Mark, Chris, and me to help you define it. I'll offer some observations about what I think it is, but let me start in the shallow end of the efficiency swimming pool. If we're looking for deep energy efficiency, we cannot ignore the interrelatedness of any of the items that go into a building project, whether it's part of the architecture, the envelope, the HVAC package, the plumbing design, the lights. All of us intuitively know this, and we know that we cannot get better than average performance, let alone deep energy efficiency, without the cooperation of the rest of the design team and buy-in from the owner. And a project may end up a bottom feeder if we don't pay attention to those interconnections. There will always be some jobs where efficiency is not an owner objective, like putting rooftops on a strip mall or a developer office project where the objective is low first cost. These may not present opportunities for deep energy efficiency, but they still should be pretty good. And getting back to the swimming pool analogy, we shouldn't be in the deep end unless we're pretty good swimmers. Another bit of my wisdom to the next generation is that we need to know what we know, and we need to know what we don't know. Now, that doesn't mean that we have to know everything, because that will never happen. But the first part means that there is a core knowledge that each of us must have to be an effective professional. We need to know the how and the why and the implications. The second part means that each of us needs to have a firm grasp on the limits of our knowledge. We need to know when to do the research, collaboration, and additional study. Now, I'm not an advocate for any of us operating outside of our personal comfort zone, but I am an advocate of doing the research and having the professional curiosity to make our personal comfort zone bigger. Take the time to visit your projects after they've been built and lived in for a while. Ask for the energy bills. I promise you'll get unfiltered feedback from which you'll learn more than reading the handbook or watching an ASHRAE webinar, although both of those would be pretty good in their own right. Stretching your comfort zone happens when we study the past and strategize about a new idea or twist. Another of my bits of wisdom is that an idea may be a good solution for the right problem, but nothing is the right solution for every problem. This is especially true when the project is an existing building where in-place infrastructure shapes our recommendations. That means if we're truly committed to energy efficiency, we need to have a big toolbox and lots of tools. And that commitment means that we might have to look beyond the obvious, dig deep, and sometimes invent a solution. Here's one possible definition. Deep energy efficiency runs on the voltage of new ideas and questioning traditional solutions. At Hamilton Heights, deep energy efficiency happened. The building was built in 1980 without air conditioning and using a tunnel induction system for classroom heating and ventilating. In 1990, DX cooling was added to the induction system air handlers. Unresolved issues from the 1990 renovation were inadequate classroom cooling, poor temperature control, temperature degradation of the primary air, and although extensive testing had found no issues, using the tunnels for supply air had raised air quality concerns. Now, the owner's project objective was an optimal learning environment, which she defined as shown here. Her secondary project objectives were an affordable first cost and energy efficiency. The design team had concerns about abandoned tunnels filling with groundwater and creating a humidity source under the classrooms. We felt that the tunnels should not be just abandoned, and that trying to fill them would be costly and difficult to ensure that they were completely filled. And we were limited by the size of the existing mechanical spaces. The proposed solution was classroom heating and cooling fan coil units and a dedicated outdoor air system, a DOAS, using the tunnels for relief air in lieu of supply air. Now, the building could have been designed to comply with the Indiana Energy Code and ASHRAE Standard 90.1 without any energy recovery, simply by breaking up the exhaust and makeup streams into smaller pieces. But since the objectives were to make the building as efficient as possible and to find an economical solution for the tunnels, we had to put on our thinking hats and get out the shoehorns. And plus, my firm's DNA means that we're going to try to save energy wherever we're working. Now, Chapter 26 of the Systems Handbook lists 8 different air-to-air energy recovery arrangements. None of them would fit into the existing fan rooms. The deep energy solution was a 2-coil DOAS unit with a changeover heating and cooling coil and a downstream reheat coil, and a corresponding heat recovery heat rejection coil in the relief air path. That part is similar to a runaround coil. Here's the piping for the DOAS unit and the relief air unit for summertime, with the DOAS unit cooling with the first coil and reheating with the second. There are 4 3-way reversing valves, and there is a control valve at each coil. The relief unit is connected to the heating water loop. This is the piping arrangement for the 2 units in winter. The 4 3-way valves have switched position. The DOAS primary coil is in heating, and the downstream reheat coil is off. And the relief unit coil is connected to the chill water system. Now, if you were paying attention, and I hope you were, a legitimate question would be, why am I cooling the relief air in winter and warming it in summer? Well, we have a heat recovery chiller back in the mechanical room, and it's piped like this. The DOAS and the relief air unit piping are similar to a runaround coil, but with the heat recovery chiller, this led to the term enhanced runaround coil. Now, this arrangement does not make any sense without the heat recovery chiller. The heat recovery chiller operates to address concurrent heating and cooling loads. Concurrent loads would typically be summer reheat and winter cooling. Now, when it's very hot outside, the air-cooled main chiller will be operating at about 1.2 kW per ton. The heat recovery chiller will be operating to meet the summer reheat demand, making chilled water at 0.9 kW per ton and getting the reheat for free. That's a combined COP of over 7. And that's what I would call a naturally occurring concurrent load. But if we artificially create a concurrent load using the coil on the relief air handler, we will still be making chilled water 25% more efficiently than the main chiller if we have a place to dump the heat. That's when we connect the relief air coil to the hot water system and load up the heat recovery machine. Now, as the weather moderates, the efficiency of the main air-cooled chiller goes up, the kW per ton comes down, and when that efficiency is better than the heat recovery chiller efficiency, which is outside air temperature somewhere in the mid-80s or around 30 C for our SI viewers, then we close the relief air coil. Then the heat recovery chiller is just picking up the reheat load, which is the naturally occurring concurrent load. Conversely, artificially creating a cooling load with the relief air handler to load up the heat recovery machine will save energy and may save money instead of running the boilers, a COP of around 5. Now, that would require a site-by-site utility rate analysis, but at Hamilton Heights, if gas costs more than 60 cents a therm and electricity costs less than 11 cents a kilowatt hour, then we save money by running the heat recovery chiller for winter heating and using the relief air handler to artificially cool the relief air. Now, smart controls are an obvious and critical piece to the solution. The heat recovery chiller operation needs to be coordinated with the boiler and the chiller to maximize efficiency and savings. An important point here: whenever there are multiple fuel sources available, there may be occasions where saving utility costs will actually increase energy use as measured in BTUs per square foot per year. The inverse of that statement is that saving energy does not always save money. And in cases like that, I would advocate for saving the money. One final caveat, when doing analyses for projects like this, remember that there are multiple dynamic variables. We have to try to identify all of them. A brief aside about the relationship between cost and energy. Here's an example from Loudoun County, Virginia Public Schools. 2 identical buildings, same location, same utility rates, different mechanical systems. Project A had gas heat, Project B was electric heat. The one with the lower site energy use, which was B, had a higher source energy and was significantly more expensive to operate. Back to Hamilton Heights. In terms of deep energy efficiency, here's how the enhanced runaround system performed versus no energy recovery and versus a conventional runaround coil. And as I said previously, it would have been code compliant to design this with no energy recovery. Comparing the before and after and recognizing and addressing all of the issues with the old system, we cut the energy use in half, lowered their utility bills by 36%, and got the Energy Star score up to 96. Here's another benefit of this flavor of deep energy efficiency. It costs less to build. And unlike most of the heat recovery solutions listed in Chapter 26, this one does not need for the makeup and the relief air paths to be next to each other. One could be in the basement and the other on the roof, but as long as they're close to hot water and chill water mains, the energy savings will be available. Another advantage versus other air-to-air options, this concept saves energy even when the makeup and the exhaust air streams are at the same temperature. And not only does it work well, I mean, that's a good-looking mechanical room. And by the way, when we were doing our prep for the webinar, one of the peer reviewers asked whether the school staff was able to understand and operate this more complicated system. And while simplicity of design is always a virtue, sometimes we may not meet our efficiency objectives without some complexity. At Hamilton Heights, there was a strong commitment from the administration for efficiency. They monitor their Energy Star scores and they take immediate action when necessary. They invested in training their maintenance staff, and they told me that the money saved from the 4 energy upgrade projects was more than 2 teachers' salaries. And concerning energy applications moving forward, let's retrofit every conventional runaround coil in every hospital, laboratory, and university science building. Okay, now that's what deep energy efficiency might look at on the design side. But like Superman and Lex Luthor, like Batman and the Joker, efficiency has an arch enemy. It's ghost energy, and it lives on the operational side of our projects. Ghost energy, another term not found in the Fundamentals Handbook, but very real and more prevalent than any of us might guess. Like thorns on a thorn bush, ghost energy has many ways to stick us. Here are some common ones, and I'm guessing that each of you could add a couple more to the list. One of the top ghosts is low delta T, which not only wastes pump energy but can also limit the capacity of boilers and chillers. I'm not going to spend time on that, but I will direct you to a vendor webinar that aired on May 24th of last year titled HVAC Myths and Realities. Now, a common winter ghost is raising the supply air temperature to address cool rooms. Now, that usually does an excellent job of heating the ceiling and a marginal job of solving the problem. Now, there's an excellent article about warm air stratification in the November 2017 ASHRAE Journal. Duct leakage. When the return air is 3 degrees colder than the coldest room? I found 20% duct leakage on a new project after it had been commissioned. Now, throughout the webinar, you're getting a good dose of Durkinisms. Here's another one. When you see stuff that doesn't make sense, chances are it doesn't make sense. Here's an example. Get your heating bills and graph the month-by-month therms per heating degree day with the winter months on the middle of the x-axis. Many, maybe most, will look like the blue line. Now, how much sense does it make that the gas use per heating degree day is significantly more in October and May than it is in January and February? Well, not much, but it reflects a phenomenon called boiler cycle efficiency, or the Nichols-McKeegan effect, namely that big boilers cannot turn down enough to meet smaller heating loads, and that boiler cycling is a big ghost. A good therms per heating degree day is going to look like this. The upper curve is gas use. The lower, the smaller hump, is the therms per heating degree day. Now, to get from the previous slide to this one, consider a heat recovery chiller or a small boiler to handle those smaller loads. Ghost energy is one ghost that we can occasionally get a picture of. Thermographic and air pressure testing of projects is always a good idea. Yes, you guessed it. That's Mark, Chris, and me tracking down some ghost energy. Thank you.
Thank you, Tom. Now it's time for our next roundtable, continuing the subject of deep energy efficiency. With the three of you being ghost energy busters, let's talk more about the concepts Tom discussed in his presentation and case study. All right, first, you would look great in one of those suits. I can see it.
Thank you.
Fits
Thank
you.
you.
All right, so we've got Tom the Ghostbuster over here. Chris and Mark, have you two found any ghost energy lately?
Well, Tom talked about a couple of them, but every blower door test always shows an unexpected hole. No matter how much detail we put into air sealing and air leakage control, we can always find a hole.
Every one?
Every one.
Oh, wow.
That surprises you?
It does.
Okay.
It does.
My firm's been working on strategies to reduce plug loads in buildings for a long time, and we've been amazed to discover that nearly half of all workstations are left on all night in most offices in the U.S.
Think about offices, a typical office, you know, with cubicles, and what exists in those cubicles? Let's see, there's a personal refrigerator, a personal microwave, a personal coffee pot, the under-the-desk space heater, the little electric charger for your phone and for your extra laptop, and the picture frame with the pictures of the kids. You know, there's a bunch of those plug loads that don't show up as regulated loads.
Very
And
interesting.
I would just like to add one thing, that you know, if we're looking for ghost energy, if we have a building that's set up on the ASHRAE EQ scale there will be a design number and there will be an operational number. And if we're operating, you know, way more costly than our model told us we should, then that's an indication of either ghost energy or a poor model.
All right. Well, let's move on to our next question. Now, Tom, you mentioned professional curiosity. What does that mean, and how does it play into improved building performance?
Well, this is me, okay? I'm going to walk into a new place, and I'm going to be looking up there. I want to know where the diffusers are. I want to know if the HVAC system makes noise. And I want to go tour the mechanical room if they'll let me. Okay, that's curiosity in there. But let me share with you a couple quotes that I came across about curiosity. Leonardo da Vinci, he wrote that that his acolytes should be relentlessly curious. Albert Einstein wrote that he had no special talent other than that he was relentlessly curious. Now, I don't know if Einstein studied Da Vinci or not, but to me, I thought that was some pretty good advice for whatever our profession is. Let's stay curious.
You know, Tom goes in and looks at the diffusers in the air handling system, and I walk into a building and I'm looking at the windows and stick my head up in the attic and find out if the attic access door's got air sealing and weather strip around it. I think the real challenge here is that the solution might require tools that aren't in our toolbox. This gets back to the discussion of holistic thinking. Okay. We've got to engage diversity of skill and talent and knowledge and ability to bring the best example.
Curiosity, I think, is what allows us to find new ways to solve old problems with old technologies and to recognize the potential of new technologies as they come along. We can't just keep doing what we've been doing. We have to be curious and understand new opportunities.
And we tend to get comfortable with the thing we know. Okay. Let's say we're on a project and somebody's been using the same window technology for 20 years because they've had really good success with it and they're comfortable with it. They may not be aware of how the window and glazing technologies available today have completely changed and could completely change the load profile of a given building. It's not that they're necessarily doing something wrong, it's just that it's a tool that's not necessarily in their toolbox yet.
Got it. All right, let's move on. Is there a savings threshold for deep energy efficiency? And we keep going back to our Ghostbuster over here for these questions.
Well, I'm not in favor of saying that there is a threshold on that. Sometimes deep energy efficiency, you might be making a silk purse out of a sow's ear with no budget, okay? Right. But you know, if somebody were to ask me for a threshold on it, if we can get an Energy Star score up into the high 90s without any renewables, then that's deep energy efficiency.
I'd like to make sure we're thinking about all the systems that are in play and not leaving any stranded assets or missed opportunities when we go into a building. So we talk about deep efficiency as being a pretty significant improvement in building performance.
To that end, I think the question we have to regularly ask is, did I leave any important stuff behind, especially the really durable stuff?
Okay. Very good, gentlemen. Let's see. What is the difference between energy efficiency in new versus existing buildings? Mark, let's go down to you for this one.
Existing buildings are a lot harder, and these guys will talk about that too, because there's facts on the ground that you have to deal with that you can't fix, a building envelope or what have you. But I think there's a lot of overlap as well, because we rely so much on building operation and successful control and long-term performance of buildings. You know, once the new building's in place, the problems are the same as the existing buildings, and the solutions are similar.
Mark's absolutely right. Existing buildings require the best of us, the best of our forensic skills. We've got to measure stuff. Every project is a one-off. It's custom because no two buildings are going to share exactly the same profile of problems or opportunities. This is where the adage that Tom mentioned earlier, let's go in and measure stuff. You know, and with existing buildings, once we measure stuff and repair those obvious problems, then we can get to the good control that Mark was talking about.
All right, Tom, you have anything to add?
I just want to say, let's measure stuff on existing building project. Let's go in there. Let's do the thermographic testing. Let's do the air pressure, and let's find the leak. Let's find the smart places to spend the money.
Can I just say that just emphasizes why it's so important to get it right in new construction, because you don't have to go back in a few years later and rip something out that should have been better in the first place.
Absolutely.
Which goes back to what you were saying about convincing the owner to do it right the first time. All right, so let's see. Tom, you said that if you're choosing between saving operating costs or lowering EUI, or Energy Use Index, go for the lower costs. Can you expand on that for us?
Well, a couple thoughts there. One is that, the EUI number, that means something to me. It means something to Chris and Mark. We know what that means. A lot of owners don't, okay? They do know what it costs to run their building. Now, so that's one thing. One is they're both measurable, but the utility costs are, more definable on the owner level. The other thing, and the other reason why I would believe that, is that if we have somebody who's arguing or thinking about whether he needs to, work on minimizing either of those two parameters, he's already at a pretty good place. So it's, it's already smart at that point.
I, on the other hand, think it's a mistake to think only of cost, because the way we pay for energy in buildings is changing really quickly, and what you think is cheaper today could be different if there's a demand charge all of a sudden, or your utility is constrained for delivery. So I think building performance has to be part of the evaluation, and it plays out as cost for the owner, so that's an important consideration.
And one of the things we'll discuss later is how there are other variables that could play into that cost. If somebody is uncomfortable, their option is to vote with the thermostat. And yet if they're comfortable and that space can be under better control, I'm going to have lower operating costs.
But it's hard to get there where people are happy and don't play with the thermostat, isn't it?
No, it requires the holistic thinking that
That's
we're
right,
talking
everyone
about.
together.
That's exactly what we're talking about.
Very good. Yes, Mark.
One of the things that actually limits our ability to deploy energy efficiency is that our energy supplies are too cheap. So if cost is the only value you put on it, you're not going to make the right long-term decisions.
Absolutely.
All right. Well, very good, gentlemen. Thank you so much. And now it is time for us to hear from you. If you have a question for our panel, please use the interface on your screen to submit it. We have questions, gentlemen. Here we go. Lillian in Toronto writes, how does a holistic approach ensure energy-efficient performance in buildings that depend on tenant behaviors, such as in hotels? Even if measures are in place, its potential might not be maximized or utilized unless the tenants are also making conscious decisions. We were kind of speaking about this just a second ago, but Mark, would you like to address this one for us?
Well, so occupant behavior, which I've been talking about a few times here, is a really important part of energy efficiency, and it's a really hard one to get at, and it depends on building type and use type. The first thing is that in the past we have not given good information to tenants that they can make decisions on to improve building performance. They have no idea what the impacts of their decisions are, how they're affecting building performance. So we need to give feedback to the occupants that's actionable so that they see the consequences and they have opportunities to improve energy performance, which means there's a whole education piece to it so that they know that the actions they take are going to save energy and they're motivated to do so. So the feedback, which is starting to creep into codes and policies and good design, is a really important part of it. There's different ways to approach different tenants. In college campuses, there's a lot of times a competition among dormitories for low energy use that relies on occupant behavior, and they have prizes for that. In hotels, of course, you have a very transitory audience, and so it's a lot more difficult. In the state of California, they require occupancy sensors, so that you drop the room key into the lock when you walk in the door, and that activates all the systems. And when you leave, if you want to get back into your room, you take your key with you, and everything goes off. So it's sort of a built-in setback that doesn't require a whole lot of occupant engagement. But in multifamily or whatever, I think it's really about making the information available and actionable to the tenants.
Mark brings up a really important point there. We as building professionals need to do a better job of communicating to everyone how they interact with buildings and the importance of buildings and what they can do. One of the things that we find in schools, for example, if they have those screens that give some feedback to the students, well, the math teachers and the science teachers and the economics teachers are writing class problems for the students to go and get data off of their school's screen and get into competition on how can we save a little bit more? What can we do that's a little different? And we need to do that on a grand scale. I think that the buildings of the future, as we do more holistic thinking, people are going to have regular feedback. Think about the feedback you get at home. It's 30 days late, you open that envelope, and it's, what if the light switch read off in dollars?
That might be, I think you may just have your $1 million invention right there.
Well, think of all of the things that we plug in.
Right.
What if they read off in dollars? We would behave differently. And one of the things that we'll see in multifamily buildings in the future, and that we'll probably see in a lot of buildings, is more rapid feedback. We've seen that in some of the smart home technology right now, more rapid feedback on the results of what's going on.
Very good. All right, call Shark Tank. I think you got something there. All right, so how do you justify larger piping and duct work first costs to allow for lower energy usage? Tom, you want to take that?
Sure. We're getting pretty deep into the weeds here I know mechanical engineer wrote that one in.
Okay.
Here's what I would say on that. Read the latest issue of Standard 90.1, the 2016 update on that, that question will be answered in there. So it's a very, very valid and smart question. ASHRAE has taken it's answered in there.
Right.
Okay, I'll leave it at that.
Leave it at that. All right, let's go to the next question. What is the role of the contractor in holistic design and constructability? How about we go to Chris?
Boy, I tell you, the contractors have a tough job because they have to manage not only all of the hundreds, if not thousands, of products that come onto a job site, but the dozens of personalities that come onto the job site. And the contractor plays a really critical role in this holistic thinking and delivering buildings that really perform. Contractors today are, for example, they're having to deal with things like pre-construction testing and mock-ups. They're having to deal with air barrier commissioning and envelope commissioning and HVAC commissioning and lighting controls commissioning. So they've got a whole lot of new things that they have to deal with. We need to make sure we're doing a great job communicating with the contractor and realize what a critical role they play in delivering a building that actually performs.
Okay, on to our next question. This is from Eric in Madison, Wisconsin. LEED requires energy modeling and awards points for buildings being more energy efficient. Unfortunately, this point-based system has pushed many energy modelers to develop optimistic models that do not accurately reflect the energy use of the building. What measures are in place to help address this issue currently in the industry?
It's an excellent question. And I would totally agree that too often LEED analyses devolve into computer gymnastics. I would advocate for taking a look at the ASHRAE EQ, which is going to measure the modeling aspect and also the in-place thing. And not that I was involved in the development of the EQ measuring scale, but I'm sure that that's exactly the reason why it was developed. And I think Chris had some. Did you work on that, Chris?
Well, Tom, I'll say the same thing Tom said in a different way. No building should get an award until it's got 2 years of operating and performance experience under its belt. We should use models to help shape decisions and help us establish targets.
Okay.
But the model is just a target. It's the delivered performance that matters.
I'd like to add something to
Please.
this. First of all, I am a big fan of measured performance as a basis for measuring buildings, but I think it's really important to recognize what a huge influence the LEED program has had on our industry.
Absolutely.
It has changed the way we do business and delivered lots and lots of really good buildings. We did a study years ago on comparing modeled and actual performance of LEED buildings. And the fact is, one of the main issues with the modeling is that you have to set a fixed expectation of how the building is going to be used. And it's never really very directly related to how the building is actually used. And so there's a big disconnect between what we model for how the building will be used and how it's actually used. If you go back and calibrate and change the inputs to the model to reflect how many hours it's actually used and how many people are in there, it's going to be a lot closer to reality.
Mark's absolutely right. We've gotten a lot better when we know how a building is actually going to be used. One thing I'll say about LEED is that it created an entire new language for us to think about with regard to building performance. We didn't used to talk about sustainability and green and understand the role of energy in that larger picture of building performance. And because of the LEED efforts over the past 15 or 20 years now, I guess, we now have a new language with which to communicate about building performance.
Very good. All right, let's see. Our next question. Are dollars the primary method of convincing a reluctant owner to pursue energy efficiency, or have you used other methods to convince key stakeholders of the value above minimum energy efficiency? Chris or Mark?
I'll take the first pass
Okay,
at that.
great.
For many years, we've been talking about productivity as the holy grail for building energy performance. And if you think about the cost to an owner of the tenants or the staff, it's 100 times as big as the energy costs per square foot. It's a huge impact. So it's tiny impact on people being less likely to call in sick, enjoying their workspace. The environmental quality can really change the economics of energy performance significantly. And energy is part of that. A well-performing building that's energy efficient is a better place to be.
Mark's absolutely right. Study after study has shown that children who have access to full spectrum natural daylight do better on standardized tests, miss fewer days of school, or more likely to graduate. Same thing with workers in office spaces and in manufacturing environments that have full spectrum natural daylight. Productivity increase of 1 or 2% trumps any of the efficiency fears of first cost.
Interesting. All right, let's move on to the next question. Does the panel have any suggestions on the best ways of helping owners understand the value of energy efficiency? Tom, you want to take this for us?
Yes. Okay. All right. I'm going to go back to what Chris concluded his holistic energy presentation about. These last probably 3 or 4 slides were all about communication and communication across the board. That's the key. That's the answer to that.
Gentlemen, anything to add on this?
It's like getting the tenants to understand the impact of their decisions on building energy. Is that owners need that kind of information as well.
All right, education.
Absolutely.
Okay. Let's see. What are your opinions on PCMs in buildings, plant-based phase change materials that have long life expectancy and the ability to reduce HVAC duty cycles by passively storing and releasing heat at a targeted temperature? This is from Drew in Halifax. Who would like to answer Drew's question?
Well, I'm going to simplify Drew's question pretty substantially. There's a lot of technologies out there that change the load shape of buildings, where we can push loads more into the daytime by night ventilation to pre-cool the building so the cooling peak isn't as high in the daytime. Phase change materials built into the walls that reduce the peak load, and he's talking about a system that reduces plant operation. All those strategies are going to become much more important in the changing utility world that I will talk about in a little bit.
Absolutely.
A little foreshadowing. All right, let's see. We don't have the funding to replace steam boilers with condensing boilers. Is there a way to modify the sequence of operations to allow the boilers to operate more efficiently? Okay. I'm looking at you. You want this one?
No, I'll take it.
Okay.
I'll take it. All right, a couple thoughts there. If you go back to my presentation about stuff that doesn't make sense, do a therms per heating degree day on your steam boiler plant. Okay, that would be one suggestion. Another suggestion is, this is probably about 10 years ago, I wrote an article for the ASHRAE Journal. It was called Understanding Boiler Efficiencies. And in there I have 10 examples of buildings where we converted site-generated low-pressure steam to the low-temperature condensing boilers that I advocate. We saved, in those 10 buildings, 2/3 of the natural gas. So we're heating the same building with 1/3 of the energy. Okay, and if you look at it that way, you're going to come a whole lot closer to, to doing some sort of a, reasonable payback on replacing those old steam boilers.
There's a lot of incentive programs to help get over the hump on funding those sort of things, both through local utilities, but even some national programs and ESCO programs to invest in those kinds of savings and help owners come up with the cash in the front. So.
Very good. All right, let's see what our next question is. You mentioned the use of heating valves for feedback to the temperature loop control. How do you account for the failure of valves, which leaves them stuck open?
Okay. Again.
Keep going.
All right,
over to Tom.
I don't know. Okay, one of the things that I like to do is I like to have a temperature sensor in the leaving side of coil piping. And, that does a couple things, but it will help you identify the low delta T if you've got, and it will also help you identify that stuck heating valve, which is going to create havoc throughout the entire system. Stuck heating valves, when they do happen, that's a big ghost.
This reminds me of one other thing that we're talking about, all the people that you should have around the table on a project. Right. Critical people to have around the table on the project are the ones that are going to be responsible for maintaining and operating it. Okay. They need to understand the objectives of the project so that they can be critical partners in making that happen.
Okay, let's go to our next question, gentlemen. What are the new technologies in deep energy efficiency? New technologies. Everybody loves new technology. Who wants to start?
Well, there's a lot of things going on in the field, but there's a lot of really progressive applications of old technologies that are making a big difference as well. A lot of passive strategies that we sort of haven't been as excited about are coming back, and I think there's all kinds of new technology and all kinds of old technology as well. But I will say that one area that has changed a lot is on building feedback, getting the information back to occupants, operators, tenants, owners about how buildings are doing. That industry has changed phenomenally in the last 5 years, and there's so much good information available about building performance now.
If you haven't gotten to know a lighting designer lately, get to know one and thank them, because they've not only come up with dramatic new lighting technologies, but more importantly, really are the lighting control technologies. Lighting controls that we didn't really imagine 20 years ago are now delivering just incredible savings. And adding one more thing to what Mark said, some of our best new technologies are old technologies. I often say that one of the problems with energy efficiency is it's boring. It's powerful, but it's boring. It's hard to get excited about insulation and windows and air sealing and stuff like that, except when you do the math. We should really be excited about insulation and windows and air sealing, and we should do a much better job delivering on those basic energy efficiency things so that when we are applying new technologies, we're getting even greater savings.
I'm glad you brought that back around to being exciting, since we're spending 3 hours on it today.
Okay.
Right. Okay. One of our fun moments was talking about the ghost energy and the Ghostbusters. So here's a question. Ghost energy, add to your balancing valve on variable speed pump. It is more correct, I don't know if this is to say, is it more correct?
Okay.
To say throttling against a variable speed pump is a waste of energy. It's possible to measure flow with an accurate balancing valve with 1 foot WG, you'll have to teach me,
right,
of pump head to within 4 to 5% of error compared to pump curve flow of measurement that is on the order of 20% error. This isn't a question so much as a clarification from someone in the test and balance world. I'm going to let you look at this because I'm sure I mangled this as I tried to read it. So help us through this, Tom.
Okay, first of all, thanks for the question. This is a very interesting thing here. I've written several articles about how I think issues like this should be handled. I am a big advocate of pressure-independent control valves, okay? And I think that pressure-independent control valves are going to do a lot of things, and they'll do several of the things, and I think probably everything that this person is asking in the question. But like I say, pressure-independent control valves, I am not a fan of throttling on the discharge of pumps with variable speed drives. If you paid for a variable speed drive, use that to balance the system.
All right, excellent. Thank you. This one's a little easier to get out. Is there some rule of thumb payback period that we should talk our owners into? Sounds like it might be a Mark question.
Longer. We need to talk them into longer. It's amazing how many projects won't even adopt a strategy that has a 3 or 4 year payback. And it has to do with their perceived risk of how long they're going to own the building.
Okay.
So we need to come up with mechanisms that allow that payback to be spread over time. So things like PACE financing, on-bill financing, all kinds of strategies are being developed to lengthen the time horizon that we use to pay back energy efficiency strategies. But we need a longer horizon.
Okay.
Payback is the wrong metric. You know, it's the least valuable economic metric we could use. And yet, it's because it's really quick math, we think that it's meaningful. We should be saying, what's the value of this investment? How long is this investment? What is your time value of money? We've got to be better communicators of the economic power beyond terms like simple payback.
Okay. Let's see. Have any of the panel looked at decentralized energy recovery units for significant reductions of energy and improved IAQ? Chris, you want to tackle that?
Energy recovery is one of those things that I'm constantly amazed at the creativity that goes on in our industry at figuring out how to use waste energy. Think, for example, about every hotel in America. what do they all have? They have these big commercial laundries. How much hot water goes down the drain? How easy is it to recover some of that heat and use it again as a preheater to the hot water supply? So there's just so many different opportunities. And we're seeing in ASHRAE 90.1 new guidelines on combined heat and power usage and things like that. So this is really an exciting area.
How many projects have you seen tap into the sewer that runs outside the building to extract heat from that as well? I've seen those presented many times.
All right, gentlemen, and this concludes our first question and answer segment. We will have one more question and answer segment later in the webcast. We will now take a short break before we begin part 2 of this ASHRAE webcast, Making Energy Efficiency a Reality. Part 2 of our webcast will begin in 10 minutes. We'll see you then.